the salvage value, which is represented by S and which is in dollars, of a company S after t years is estimated to be given by this formula. So S of t is equal to 600,000 times 0.9 to the power t. Okay, so that is the salvage value we have given. Our goal is to find what is the rate of depreciation after 1 year, and then the rate of depreciation is also in the dollars per year, but our goal is to figure out what is the rate of depreciation after 1 year. So this is the question. So let's try to formulate the given information. Okay, so we have given the salvage value, so that means S of t, right? So S of t is given as 600,000 times 0.9 to the power t. So this is the given information, but our goal is to figure out what is rate of depreciation. How do you find the rate of depreciation? Well, we just find the derivative of S. So find the derivative of S with respect to t. Okay, that will give you the rate of depreciation, but you need to figure out the rate of depreciation after 1 year. So that means you need to find S prime of t when t equal to 1. So this is the question. Okay, so after extracting the information, let's try to just work on this formulation. So we have figured out that S of t, we have given that S of t equal to that function over here, right? So and then our goal is to just figure out the derivative at 1. So let's do that. Okay, so S of t is given as 600,000 times 0.9 to the power t, and our goal is to find the derivative of that with respect to t, right? So that's how we can compute S prime of t. So let's do that. Find S prime of t. So how do you do that? So we have here a constant multiplied by some function. So we can use the constant multiple rule, which is leave the constant as it is. So 600,000 is as it is, multiplied by the derivative of 0.9 to the power t with respect to t. Okay, so let's do this. So this is 600,000, which is as it is, multiplied by, how do you find the derivative of 0.9 to the power t? We have the formula available, which is if we are differentiating any general exponential function raised to the power t, then the derivative is b to the power t times ln of b. Okay, so that's the exact general exponential function we have, where the base b is 0.9, right? So that's what we have. So let's apply that formula. So when we apply that formula, you can see we can write down b is 0.9. So 0.9 is as it is, raised to the power t, right? So times, since we have ln b, we also need to multiply by the ln of 0.9. Done. That is the rate of depreciation, but I don't know what does that number mean, right? So let's try to see what is ln 0.9 mean. So if you evaluate ln function at 0.9, probably you will get around negative 0.105, approximately equal to that. Okay, and multiply by, okay, and then you need to multiply by this. But our main goal here is to evaluate the derivative. So we have figured out S prime of t, but our goal is to evaluate the derivative at 1, right? So that means we need to figure out S prime of 1. So if that is the case, then why don't we just plug t equal to 1 in and evaluate what is S prime of 1, so that we can compute everything on the calculator together. Okay, so 600,000 times 0.9 to the power, replace t by 1 times ln of 0.9. And now if you correctly input everything in your calculator, I believe you will receive approximately equal to minus 56894. So 50 minus 56,894.68. Okay, and if we round to the nearest cent, remember that everything is in dollars, so if that is the case, then 0.68, so we have 68 cent there, right? If you round up to the nearest cent, that's what we get. So this is the rate of depreciation we get after 1 year for the given salvage function.